Deep in space, our Milky Way galaxy and its neighbor Andromeda are hurtling toward each other at over 4 million kilometers per hour. For decades, astronomers believed a head-on collision was inevitable, but recent data reveals it's actually a 50-50 chance. We know Andromeda is heading our way because of blue shift. When an object moves away, its light waves stretch out and turn red, but Andromeda's light waves are compressed, creating a blue hue that proves it's rushing directly toward us. When we try to picture a galactic collision, human intuition paints a catastrophic sci-fi disaster. We imagine a chaotic battlefield of shattered planets, colliding moons, and exploding stars raining fire. This mental image ignores the reality of the cosmic scale. Between the hundreds of billions of stars in these galaxies lie light years of sheer, terrifying emptiness. Because star systems are separated by such vast stretches of nothingness, the mathematical chance of our sun actually hitting another star during this merger is effectively zero. This diagram maps out the true scale of the Milky Way. It is 100,000 light-years across. That means a beam of light would take 100,000 years just to get from one edge to the other. The gaps between individual star systems are unfathomably wide. Because of these extreme distances, the billions of stars in both merging galaxies won't crash at all. They will simply slip past one another like ghosts. But that doesn't mean a merger is entirely peaceful. The objects that actually physically collide are the massive, sprawling clouds of interstellar gas and dust floating between the stars. When these massive gas clouds crash, the resulting friction and shock waves violently compress the material. They ignite a chain reaction known as a starburst, instantly birthing billions of new stars. There is one rare exception where stellar collisions do happen, inside ultra-dense stellar traffic jams known as globular clusters. When mature stars crash in these crowded pockets, they merge into hot, rejuvenated bodies called blue stragglers. Astronomers were only able to prove these merged blue stragglers existed by using the incredibly high-resolution lenses of space-based observatories, like Hubble, to separate the distinct points of light and analyze their abnormal heat. These mergers function as violent cosmic nurseries, where the friction of the crash triggers the explosive creation of a new generation of stars. The fastest and most violent stellar collisions happen between dead neutron stars. Caught in a gravitational death spiral, they whip around each other thousands of times a second before finally crashing. The instant they touch, they trigger a gamma-ray burst. This invisible shock wave of radiation releases more energy in a fraction of a second than our sun will produce over its entire lifetime. We had no idea these cosmic bursts existed until they were caught by accident. During the Cold War, U.S. military satellites launched to monitor nuclear test ban treaties inadvertently detected these massive flashes radiating from deep space. Scale that energy up to the very center of a colliding galaxy, where supermassive black holes merge. The friction of matter falling into these gravity wells can weaponize radiation into intense jets, capable of completely sterilizing any neighboring planetary systems. Heavy cosmic dust hides these central black holes from optical view. To see them, astronomers have to use massive, synchronized terrestrial arrays to pierce through the debris and detect their faint radio wave emissions. While the vast majority of planets and stars easily survive the wider collision, the galactic core itself becomes a highly lethal radiation zone, entirely dictated by the merging black holes. Because a galactic crash takes billions of years to unfold, we can never observe a full event in human time. We have to compress the timeline using advanced computer models known as the Tormry sequence. This simulation models the initial pass of the collision. As the two galaxies fly through each other, their immense gravity rips out millions of stars, dragging them into massive trailing lines called tidal tails. Momentum carries them apart, but their mutual gravity acts as a pendulum brake. It eventually halts their outward spread, yanking the two cores back together for a final, inescapable merger. The distinct, beautiful spiral shapes of both galaxies will be permanently erased. They will settle into a single, featureless elliptical galaxy, a new cosmic entity known as Milkomeda. So, what happens to Earth during the Milkomeda merger? There is a small chance our solar system will be harmlessly flung out into one of those tidal tails, leaving us drifting in the distance with a spectacular front-row view of the merging cores. The galactic collision poses almost no physical threat to the structural integrity of our solar system. Earth faces a much more immediate deadline within our own solar system. Billions of years from now, coinciding with the galactic merger, our sun will exhaust its core hydrogen fuel and expand into a red giant. This massive expansion will boil our oceans and strip the atmosphere away. Earth's life will end due to the natural, unavoidable life cycle of our host star, completely independent of the spectacular cosmic crash unfolding in the background. We tend to view crashes as the ultimate end of the line, yet the universe uses them as engines of creation, forging trillions of new stars and worlds from the ashes of the old.